Hey guys, thanks for joining this tutorial. In the previous video we talked about functions in Solidity, and today we're going to take a look at some additional Solidity functions, also called special functions. Well, we have the following special functions in Solidity. We have getter functions, a constructor, the receive function and the fallback functions. So let's take a look at each of them. Whenever you declare a public state variable, the compiler automatically creates a public getter function, which allows you to retrieve the value of the state variable. However, if your public state variable is an array, the corresponding getter function allows you to retrieve only one array element at a time, by specifying a valid index of that array. If you want to call the getter function from another contract, you simply specify the name of the corresponding state variable with the brackets. The constructor is called only once during the deployment of the contract, and it allows you to initialize the state variables of the contract. We can also provide arguments, and if you want to transfer funds to the contract during deployment, we need to add the payable keyword to the declaration of the constructor. Each contract can have one receive function. The function cannot have any arguments, it cannot return anything, and it must have external visibility and be payable. The receive function is executed on plain either transfer via send or transfer. Also, the receive function can rely only on 2300 units of gas. So this means you cannot execute much code in this function. Typically you will emit an event in the receive function, but you cannot update any state variables because that requires more gas. Also, each contract can have one fallback function. The function needs to be external, and optionally it can accept one argument of type bytes call data, and it can return one argument of type bytes memory. The fallback function is executed on a call to the contract when none of the other contract functions matches the provided function signature, or if no data was supplied with the function call, and the contract doesn't have a receive function. If the fallback function needs to be able to receive ether, it needs to be marked payable. If a contract needs a receive function or a payable fallback function, it cannot receive ether for a regular transfer. Okay, let's take a look at some code examples. Here we have two simple contracts. The first, the special functions, the contract where we will define our special functions. And we also have a second contract, test special functions, that will allow us to test our functions and to trigger especially the receive and the fallback function. Okay, so let's get started with our special functions. So, as we already learned, if we add a public state variable, the compiler automatically generates a getter function for us. So let's say we create an unsigned integer, make it public, and call it, for example, value. So in that case, the compiler will create a getter function with the same name, value. However, it's important to specify the public keyword. For state variables, we can use private, internal and public. If we don't specify any keyword, by default, the state variable will be internal and no getter function will be created. So in order to call the getter function, let's take a look at our test special functions contract. We already have a function signature for get value. And in the test special functions, we have an instance of our special functions contract. And all we need to do is simply call the function on our special functions contract. So the variable name is sf. We simply specify the name of our public state variable and we add the brackets. So later when we test the function, when we deploy the contract and test the function, we'll see we can access the value of our public state variable. So now let's take a look at the constructor, which allows us to initialize state variables. We'll simply define the constructor using the constructor keyword. And in our case, we specify an argument, an unsigned integer, Let's call it underscore value. Okay, and during the execution of the constructor, we simply initialize our public state variable as our underscore value. Next, let's take a look at the receive function. The receive function is triggered on plain ether transfer, and it needs to be external and payable. So to define the receive function, we don't use the function keyword, we simply use the receive keyword. No arguments allowed. It needs to be external and payable. And we need to be careful because we only have 2,300 units of gas. This means we can't really do much in this function. So typically we will emit an event in this function. We already have the receive ether event, so we just use this one. So we specify the sender, which is the message sender, and also the transferred amount, which is the message value. And we can also log the current balance of the contract, which is simply address of this, which is the contract, and the balance of it. And finally, let's have a look at the fallback function. Define the fallback function with the fallback keyword. The fallback function also needs to be external. It can be payable in order to receive ether if there is no receive function. In our case, we already have receive function, so we just leave it this way. The fallback function is executed on a call to the contract when none of the other contract functions matches the provided function signature. What we can do here is we can just change the value of our public state variable. Let's say we just set it to a constant or whatever, doesn't matter. So in order to trigger our fallback function, we need to call a non-existent function on our special functions contract. Something like, for example, test. Test function doesn't exist, so this will trigger the fallback function. However, we can't just call it because test doesn't exist, so we need to issue a low-level call. In order to issue a low-level call, we cast our special functions contract instance to an address, and we can use the call method, and in the call method we specify the function signature. Something like this, for example. Test doesn't exist, so that's a valid function signature. However, we can't just call it like this, we need to encode the function signature. In order to encode the function signature, we use the ABI encode with signature function. The call returns a boolean, so we can check the return value, for example, like this. We require that the boolean returns true. That's it. Oh, we forgot a bracket here. To trigger the receive function, we need to send some funds to our special functions contract. And once again, we cast our special functions instance to an address. And we also need to make this payable. and we use the transfer method. We could also use the send method. We transfer, for example, 50 way. So that's fine. Okay, we also forgot a return statement here. Now it's time to test our contracts. We first deploy the special functions contract, and we specify an initial value in the constructor. Let's set it to 5. We deploy the contract. So when you check the value, of course, it will be the 5, the value we deployed in the constructor. That's fine. And we also have a second function to test the balance. Initially, the balance will be 0. So now we take the address of this contract, we copy it, and we deploy the second contract, the test special functions, which needs to specify the address of the first contract in the constructor. So we specify the address here, and the construct is payable, so we will also send, let's say, 100 way. Okay, we deploy the contract. Now in the second contract, we can test our getValue function. Well, this should return 5. It calls directly into the getter function. That's fine. And now we test the trigger fallback function. The trigger fallback function, we simply call a function that doesn't exist. So it will trigger the fallback function in our special functions contract and set the value of our state variable to 10. Call trigger fallback, and now the value will be 10. You can also check the state variable in the first contract, which will be the same, of course. Well, that's fine. Now let's test the receive function. When we call the trigger receive, we just transfer 50 way, which should emit an event in our special functions contract and change the balance of the contract. Okay, let's clean this out. We call trigger receive. So this is fine. Let's just take a look if the event was triggered. Yeah, we have an event. We have the various parameters. So the first parameter is the message sender, which is just our contract. The second is the amount we sent, and the third parameter is the balance of the contract. So now if we check the balance, which was 0 previously, it will show 50 way. That's fine. Okay, that's it for today. Thank you so much for watching, and I'll see you in the next video.